myself Dr. M. Laxmidevi, Associate Professor in the Department of CSCDS at Institute of Aeronautical Engineering. In this video lecture, we learn about enumerated data type. So it is also called as enumerator or enumeration. Then the other topics which we will be covering in this video lecture are typedef and then Bitfields in C. Now, let us see the first one, enumerated data type. So these are also called as enumerators. So enumerators, enumerations, enumeration or enum. So all of them, they refer to the same type. So that is enumerated data type. Enumerated data type, it is a data type, you can say. It is also referred to as enum. This is a keyword, you can say. It is a user-defined data type. So we have seen there are different types of data, different data types we have: primitive data type, user-defined data type and derived data type. So in the category of user-defined data type, this enum, this data type comes into picture. So enumerated data type. So it is mainly used. So we can say that this is the definition of this enumerator or enumeration. So it is, this is the data type. It is a user-defined data type which is used to assign names to integral constants. So this enumerated data type is used to assign names to integral constants. So because of this, suppose in the program we need to use more than one constant. Suppose 3, 4, 5, 6, 7, 8. So these list of constants are to be used in the program. So in order to use these constants, so we need to we can make use of this data type, that is enumerated data type. So enums make the code more readable and maintainable by providing meaningful names to the values instead of using raw integers. So instead of directly specifying these integral constants, so instead of them, we can give a name to this particular, we can assign name to this integral constant, and then we can make use of that name. We can use the name in the program. So because of which the code becomes more readable and maintainable. Now let us see the syntax of enumerated data type. So this is how we declare an enumerated data type. So the keyword to be used is enum. Then after that, the name of the this enumerated data type name. So inside the curly braces, so we have value 1, value 2, or you can say constant 1, constant 2, and so on. So this depends upon, so these are separated by comma. So each of the constants, they are separated by comma, and at the end we have a this is the end of the curly braces followed by semicolon. So in this way we can declare the enumerated data type, so with the help of the keyword enum. Now coming to the declaration of the variable, so just defining the user data type is not sufficient. So in order to allocate memory for that particular data type, we need to declare the variable. So this is how we can declare the variable for enumerated data type. So this is the first method and this one is the second method. So either or out of these two, you can use any one method. So keyword enum, this specifies that this is a user defined data type and day is the identifier. Then inside the curly braces, so which is each of the constant. This is constant 1, constant 2. So these are separated by commas, and at the end we have a semicolon followed by the variable name. So this is the variable which belongs to the data type enum day. So these are the names, you can say. These are the names which have some integral constants. So these are the names which are given inside the curly braces. So another way of declaring a variable is enum day. So in this is 2 lines we are using. This is in single line only we can declare the variable. So here first we need to define the data type, then what are the names which we have used, and then after that, so this is enum, and then this is the variable which is declared of the type, which is of the type enum day. So these are the 2 ways. So today is the variable name. So here day is the variable name. And this is the identifier. Here this is the identifier. Next, coming to the example. Now let us see one example how to use this enumerated data type in programs. So first of all, we need to include the stdio.h header file. Then, so here this is the global declaration. So we have declared a data type of enum day. So inside this we have, so these are the names of this enumerated data type. You can say, so Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. Then at the end we have a semicolon. In the main function, so we are declaring the variable for this data type enum day. So this is the variable. The name of the variable is today, and it is assigned a value Saturday. So here whatever the names we have specified, so out of this one value is assigned to this variable. So if you try to print the value of this, so if you use %d as the format specifier and try to print the value of this variable, so you can see that the output of this program is 5. So why? Because so the compiler will automatically, so let us see the definition once again. So definition here is nothing but enumerated data type, or it assigns names to integral constants. So this is the definition of enumerated data type, or enumerator, or enumeration. So here whatever the names we have, so the compiler will automatically assign some integral value to these different names which we have used in the data type. So this is the first name, Monday. So if we don't give any values to these names, so compiler will automatically initialize these names with some value starting with 0. So this will take a value 0. So this name will take a value 1. So this is 2, 3, 4, 5 and 6. So therefore when this name is assigned with the help of this statement, you can see that the value of this variable is, so this name, the integral constant assigned to this name is 5. So that's why we got the output as 5. Next, one more program we'll see. So here same thing we have declared. So another important point we can see in case of enumerated data type is, so if the values are, so we can specify the values here itself. In the declaration itself, we can assign values to these names. So here Monday is assigned a value of 1, Tuesday is assigned a value of 4. So what about the value of this name? So this is not assigned any integral constant, or any value has not been assigned to this. So value of this is decided based upon the value of the previous name. So value of this will be 4 plus 1, which is equal to 5. Now here this name Thursday has a value of 8, whereas Friday, this is not assigned anything. So therefore it will have a value 9, because 8 plus 1 is 9. Next, this is not assigned any value. So this will have a value 9, this will have a value 10, and this will have a value 11. So therefore, with the same statements which we have discussed previously in the previous program, so if we are declaring a variable of, the name of the variable is today, it is a variable of type enum day, and it is initialized with the value Saturday. So it is initialized with the name Saturday. Then if you try to print with the help of printf statement, you will get the answer as the output of this program is 10. So why? Because according to this logic, you can understand. Monday has been assigned a value 1. Then Tuesday, if there are no values assigned, then the value of that particular name will depend upon the previous value. So here for this variable, for this name, value is 8. Value assigned is 8. So therefore it will have a value 9. So 8 plus 1. So in this way, we can understand this program. Next, one more example. So we can make use of this enumerated data type in switch cases also. So this is the declaration part. So here we have declared an enumerated data type enum day, and then so these are the names which we have used in the declaration, or you can say this is the definition, enum definition. So in the main function, so we have declared two variables. So first one variable is today, and the next variable is favorite day. So today is a variable of type enum day, favorite day is also a variable of type enum day. So this is assigned a value, this is assigned a value Wednesday, whereas this one is assigned a value Friday. So we can use enum values in switch statements also. So we have seen the syntax for switch case. So along with some examples also. Switch is a keyword which is to be used, and inside these brackets, so we write the expression. This expression should be an integral constant. So here today has a value Wednesday. So it will match with the cases. So case Monday, so case Wednesday. So Wednesday and Wednesday both are matching. So therefore, whatever the statements are followed by after this case, so that will be printed. So output of the statement will be in output of this program is it's Wednesday. Now coming to enumerated data type, so we can do the same thing. We can assign names to integral constants with the help of by using the other preprocessor directive, by using a preprocessor directive which is defined by hash define. So hash define is a preprocessor directive. You can say that this is a macro. So we can assign names to integral constants by using this also. So if you write in this way, so wherever instead of this, so pi will be replaced by 3.14 in the program. But what is the difference between enumerated data type and this one is, so we can go for, so enum data type, it follows the scope rules. So enum, it follows the scope rules. So that means we can define this data type inside the main function also, and we can declare the variable, and then we can use that variable in this particular function also. Whereas coming to this hash define directive, so these variables, so this name is this is global declaration. So this has to be in global declaration, whereas enum follows the scope rules. And other important point here is we no need to. So when we declare a data type of enum, so the compiler will automatically assign values to the names. So here the compiler will not assign values to the names. So we have to explicitly give the value, whereas in case of enum, the compiler will implicitly assign values to the names. So that is the difference between this one preprocessor directive, that is hash define, and enum. Then applications, coming to the applications. So first application is, so these are the various areas where we can use enumerated data type. So error codes to handle error codes, game development, machine learning labels, database codes. So there are other applications also, wide variety of applications where we can use enumerated data type. We will discuss these four. So these enums can be used to define error codes in a program. So each error code can have a meaningful name, making it easier to handle and specify, making it easier to identify and handle specific errors. So next, in game development also, these enums can be used. So these are often used to define various game states. So character types, item types, and other game related constants. So we can also use it for machine learning labels. So in machine learning, enums can be used to represent different classes or labels in classification task. Then database codes. So enums can be used to represent codes or categories stored in databases. So next, coming to typedef. So typedef is a keyword. So it is a keyword. So with the help of this keyword, what it does is it creates a new name. So, or we can say that it creates an alias for the existing data type. It does not create a new data type, but it creates an alias or new name, you can say, for an existing data type. So that is what the use of this typedef keyword is. So typedef keyword is used to create new type name, alias, or you can say synonyms for the existing data type. So for example, so we already have we already have the data types, primitive data type like integer, float, etc. So int a means this specifies that a is a variable which stores integer value. So if we precede this statement, if it is preceded by typedef, so if it is preceded by typedef, then we can say that this is the new name. This is the new name given to this. We can declare variables of the type A. So all the variables of type A, they belong to integer type. Now we can understand it with the help of programs. This can make the code. So typedef keyword is used to create new type name, alias, or you can say synonym for existing data types. So this can make the code more readable, maintainable and abstract by giving descriptive names to data types. So typedef, it does not create a new data type. So this is the important point to be highlighted. So we do not create any new data type, but it simply provides an alias for the existing one. Now let us see the syntax for this typedef. So syntax is typedef existing data type and then new type name. So we'll illustrate it with the help of, so this is one program. So you can see here, so this is the typedef statement. So this is the keyword followed by the data type is integer. After that, with the help of this syntax, so we can compare these two, syntax and this statement. So this is a keyword to be used. Existing data type is integer. New type name is age. So we can define now variables of the type by specifying the name age. So in the main function, so when we write the statement in this way, age and then percentage. So percentage is a variable of type age. So we have explicitly said here that age is the name given to integer data type. So therefore, this will give the value 25. So in this way, we can use typedef keyword in order to give a new name, or you can say alias for the existing data type. So this typedef can be used with structures, unions, then pointers, etc. So structure is a user-defined data type. So these are the two ways in which we can use typedef. Typedef, and then this is the structure definition. Structure definition. Then after that, this point is the variable. So this is the new name given to this data type. So struct. So instead of specifying struct, so this is another way where the way in which we can define the structure data type. Struct P1 is the name of the, this is the data type. Struct P1 is the data type. And then this is the new name which is given. So every time, so without using typedef, we can write this as, so every time we need to declare, so in the int main function, we have to declare it as struct P1 and then the variable name. Suppose P is the variable name. So this is the variable name and this one is the data type. We have to write. But by using typedef, so we can avoid this statement repeating again and again. We can avoid this. So we can replace this data type with a new name. Suppose the new name is point here. Now every time you want to declare a variable of this type struct P1, so we can simply write point P. So if you want to declare another variable of this struct P1, so we can write point Q. So in this way, we can use typedef with structures. So when we run this program, output of this program is, it will simply display the coordinates p.x and p.y. So p is a variable. We have defined p is a variable of type struct P1. So for this type struct P1, we have created a new name, or we have given alias. We have created an alias for this type, data type. The alias name given is point. So with the help of this, we can create variable of this data type and then we can use it in the program. So one more example. So we can use typedef with enum also, enumerated data type. So this is how we can use it. So typedef followed by the enum keyword and then day. So inside this, this is declaration. So here itself we need to specify the type itself. Here itself we need to specify the type. So this is nothing but the name or alias name, you can say. So this is the new name given to this data type. So every time we want to clear, so without, if this typedef statement, if this typedef keyword is not there, so we have to declare a variable in the int main function as enum day and then suppose d1. Now we can replace this with this. So this is the new name given. Instead of this, we can write today d1. So that is what we have done here. So d1 is the variable of type today. Today is the new name given to the data type enum day. So if you try to execute this program, so you will get the output as today is 1. So why? Because Tuesday. So we have not initialized this enumerated data type. So the compiler will automatically assign values to it. So integral constants to it. This is assigned a value 0. So this is assigned a value of 1. So the output of this is 1. Now we can use typedef with pointer variables also. We can give a new name to a pointer variable also. So suppose this is the pointer variable. Int star is a pointer variable. We need to declare a pointer of type integer, which is pointing to integer. And this is the new name which is given. So by using this new name, we can declare pointer. We can declare integer pointers. So this P1 is integer pointer and this P2 is also integer pointer. So thus by using typedef, typedef is nothing but a way of giving new name or to create alias. It creates aliases for the existing data type. It does not create any new data type. Next concept is bitfields. So what is bitfield? So when the concept of memory optimization or efficient usage of memory comes into picture, so there we have to use bitfields. So bitfields are used to store data in a space efficient manner. So when we actually know when bitfields are generally used with structures or unions. So these are used within structures or unions. So we can define the number of bits each field uses. So suppose, for example, so if we know that a particular member of this structure cannot have a value more than, suppose the value for a member, it ranges from 0 to 7. Then now we know that this particular value is stored in the memory as in the computer it is stored as in the form of bits. So 7 will have a maximum value. So this will require, 7 value requires 3 bits. So convert it to binary form. So 2, 3. So 1, 1, 1. So this is a binary form of 7. This is a binary form of 7. So in computer, 7 is represented as in this way. So therefore 3 bits. So we say that 3 bits are required for this in order to store the value 7. So only 3 bits are required. But when we say that integer a and assign it in this way, a is equal to 7. So compiler will allocate 4 bytes for this because it is declared the data type of this variable is integer. So and integer requires 4 bytes. So instead of wasting the memory, so by specifying the values, by specifying the number of bits, we can actually save the memory. So that is what the concept of bitfield is. So these can be used within the structures or unions. So we can define the number of bits each field uses. So when we need to optimize the memory or use the memory efficiently, so there the concept of bitfield comes into picture. So syntax for this is, so bitfield concept is used in structures on unions. So for example, struct is the keyword. So this is the syntax how to declare a bitfield variable. So here data type is, then after inside this curly braces, we need to specify the data type, then followed by the member name. And after the colon, we need to specify the width. So at the end, we have to put a semicolon. So here data type is nothing but, so this data type is nothing but, it is an integer type that determines how a bitfield's value is interpreted. So this data type, it can be integer or unsigned integer. Member name is nothing but the name given to the bitfield, name of the bitfield. Width specifies the number of bits in the bitfield. The width must be less than or equal to the bit width of the specified type. Now this is how we can define bitfield. So bitfields are variables, you can say, so which are defined with the variables defined with a predefined width. So or size, you can say. The variables which are defined with a predefined width or size, they are called as bitfields. So for example, a bitfield can hold more than a single bit. So for example, if you need a variable to store a value from 0 to 7, then you can define a bitfield with a width of 3 bits. So that means, so for representing 7 in the memory, 3 bits are required. So therefore, we can mention in the field, so we can specify the bitfield width as 3. Now let us see with the help of program. So this is the structure definition. So here in the structure definition, this is a regular structure. This one is a regular structure and this one is this regular structure specifying the bit field. So this is without bit field, and this one is with bit field. So in this program, so we have defined a structure without bit field, without specifying the bit field. So in this program, we have defined a structure by specifying the bit fields. Now let us try to execute. Let us see the program. So here this is a regular structure. So we have defined three variables of type integer. So all of them they belong to, and the modifier here is unsigned int. So memory required for this is, so there are three integer type members. So each of the member requires 4 bytes. So 4 into 3, so that is equal to 12. Now in the main program, what we have done is we have created a variable of type struct flags. So this is the name of the structure, struct flags. We have created a variable of type struct. So this is the variable name. And when we try to print the size of the struct flags, so we'll get the output as 12. So this is the output of this program. So where we have not used the concept of bit field. Now if you try to use the concept of bit field, so in order to use bit fields, we need to specify the number of bits. So this is how you can specify. So this is the individual member of the structure, unsigned int flag 1. So semicolon after that followed by, so this is the bit fields. So 1 bit for flag 1. So unsigned int flag 2. This is also, so here also we have specified the width of the bit field as 1. So here also we have specified the width of the bit field as 1. So with this, the programmer already knows that, so this particular member will not have a value. So will not have a value which will occupy more than 1 bit. So that is what this means. So struct flags, we are creating a variable of this type structure. And then when we try to print the size of this struct flags, you can see that the output of this program is 4. So why? Because we have used only 3 bits. So 3 bits. So therefore the size of this, when we are specifying this with the help of bit field, the size of this structure is 4. So thus instead of using 12, so we can use only 4 bytes. For this, we can use only 4 bytes. So this is how in which we can optimize the memory, or memory can be utilized efficiently. Now let us see one more program. So here we have defined this structure with, this is regular structure and this is the structure with bit field. And this one is without bit field. Now we have declared a variable of type struct flags. So variable for this one declared is flags, and variable declared for this one is new flags. So this is the variable which has been declared. Now if you try to print the size of the structure, so here if you try to print the size of this structure, so the output of this is 12. So why? Because we have declared here, we have defined there are 3 members of the structure and each member is of type integer. Integer type requires 4 bytes, therefore 4 into 3, that is equal to 12. So next, if you try to print the size of this structure variable with bit field, so size of struct new flags. So this size of this is given as 4. So why? Because here we have only 3. We have specified this with this. The structure here is defined with the members, and each member has a width of, the bit field width is here is 4. So this is having a width of 1 and this is having a bit field of width 1. So 3 plus 1, 4, and then 5. So total bits required for these members are only 5. Now if you assign a value for this flags, for this member of this structure, flags.flag1 is equal to 7. Now if you assign a value of 7 to this member also, so that is new flags. So this is a variable name. We can access each member by using dot operator. So variable name dot the member name, new flag 1 is equal to 7. So this member is assigned a value of 7. So we have specified that here this member requires only 3 bits. Now let us see the output of this program. And if you try to print the value of this member and the value of this member, first member, so which have been initialized with 7 and 7. So both the members have been initialized with the value 7. Now let us see the output of this program. So first one is coming as correct only, same value what we have given, what we have assigned, same value we are getting. But for the second case, that is for this member where we have specified the bit field, the value is coming as -7. So why this is the case means because we have specified here as integer. So this is signed integer. So integer means by default it will have a modifier signed integer. So signed integer will have values from positive values as well as negative values. So this 7 will be interpreted as 7 requires 3 bits to be stored. So 3 bits means, so 1, 2, 3, 3 bits are required. So in the memory 7 is stored as in this way. So if it is the data type, we have given it as signed integer. So signed means this MSB, most significant bit, is the signed representation. We convert it to, so 2's complementary of this one is 0, 0, 0. So plus 1. So you will get it as 1. So this is signed integer, therefore you will get it as -1. So therefore you are getting the output as, so you are getting the output of this variable as, so this member, you are getting the output of this member as -1. So now in order to avoid this, what we can do here is, so we can simply assign a modifier to this variable, simply assign a modifier. So we can specify it as unsigned int. So since we know that, so if a particular member, it occupies or it requires only positive values, we actually know that if the particular member of that structure will hold only positive values, then it is better to use this modifier unsigned int. Now with the help of this, we can get the output as 7. So same program we have executed here, but in this what we have modified here is, so previously we have not written any modifier here. So it is signed integer. Now we have converted it to unsigned integer. So unsigned integer and the same value, this member is assigned a value of 7 and this member is assigned a value of 7. So output, if you try to print the values of the individual structures, individual members, so you will get the output as 7 and 7. Next is one more program, let us see. So these are two structure definitions. So one is without Bitfield and the other one is with Bitfield. So this is without Bitfield and this one is with Bitfield. So bits, corresponding bits here mentioned are 3. So for this member, the bit value is 1. For this member, the bit field is 1. The width of the bit field is 1. Now let us see the program. So we have two structure definitions. We have declared variables for the two structures. So for this structure, flags is the variable. For this structure, new flags is the variable name. Now we are trying to print the size of, in order to determine the size of each structure. So size of regular structure is 12 because it has 3 integer members. So size of each integer member is 4. So 4 into 3, that is equal to 12. Next is size of structure with bit field. So when we try to determine the size of this structure where we have used bit fields, so size of the structure with bit field is 4. Now if you try to assign a value of 8 to this member of the structure, and if same value we are assigning to this structure also, so to this structure member also, and if you try to print the values of these two members, so you'll get the output as 8 and 0. So regular structure, there is no problem. Whatever we have assigned, we'll get the same value. But when we are using bit fields, so whatever bits we have specified, the output will be truncated. So you'll get a warning here. So large integer is implicitly truncated to integer type. So this is a warning you will get, and the output obtained in this, in the case, output obtained for this statement is, you will get the output as 0. So that's why the output will be accordingly, it will be according to the number of bits which you have specified in the structure definition. So this you have to take care of. So when you are using the concept of bit fields. So that is all about the concepts of enumerated data type, typedef, and one more we have seen. So that is Bitfields. So in the coming video lectures, we'll discuss some more topics of C programming. Until then, thank you.
Like, share and subscribe. Hit the bell icon for more updates.